I'm Felipe from Brazil, and I'm going to try to ride you guys through a quick, brief train thought of the motivations behind Paratii. And then I'm going to bring in Yaya, which is an Egyptian software engineer that has done most of the work that our team has done when it comes to P2P. And he's going to talk about the technicalities of browser-to-browser streaming of video, basically. So I'm first going to go over the context and motivation behind IT. I'm going to outline our vision for video in the Web3, and then I'm going to hand over words to Yaya. Our mission is basically to carve out new revenue streams for content makers and to help build infrastructure that enables decentralized applications. And we come from the other side of the table. So we come from film production and audiovisual production backgrounds, part of the founding team. So we know how hard it is to monetize content when you're not making the content that a certain platform is aiming to optimize for. And we know how much talent and creativity gets wasted because of that. Yet we see a lot of innovation flourish whenever technology spawns new formats for content. So we've seen this happen with TVOD and short format content that flourished on the early web. We see Yaya, or no, maybe we see. We saw vlogs and content from 8 to 12 minutes, to say so, flourish when streaming improved its quality, and we saw the emergence of YouTube and the advertising-based video models. We saw very short formats emerge and find their way to earn capture with Snapchat and one-to-many broadcasting on mobile. And we keep seeing new formats flourish whenever technology brings us to a new stage and allows us to do new stuff. So I like to think that technology enables and emancipates creativity in this sense. But businesses teach us some things, and one of them is that value capture is much more important than value creation, specifically in the media industry. So in the end of the day, we get to a scenario which we've all discussed many, many times before, where the big entities out there basically optimize for over-harvesting user data. And then we get to these expressions and concepts, which we've also discussed many times before, which describe a bit of the state of the landscape for publishing and for monetizing video content today. We have networks that are in a state of surveillance by default, as we know, and we have an industry that is plagued, to say so, by investor story time. And I don't know how many of you guys are familiar with that expression. Maybe if you could raise your hands, whoever's heard that before. Cool. So if you go to this text, you'll find it. An investor story time is basically building a product for investors instead of building a product for consumers. And it's what leads these huge media entities out there to optimize for over-harvesting user data and to promise to their investors that they're going to make advertising more effective in the long run in a never-ending cycle, basically. So realizing the swamp that the media business is at is a rabbit hole on itself. I truly believe that programmable money and fractional ownership in certain aspects can help us get to the next monetization models for video on the web. I'm not going to go deep into details here because this is one of the things we do at Paratii, exploring monetization in the apps we build, and the other is helping build infrastructure, and that's where I want to get. If you want to read some of our texts or some of the references, they're all online. And the big takeaway here, I think, is that there's a lot of opportunities and a lot of stuff to be explored, but just as the guys previously here mentioned, this is pretty much still in research and development mode, and we need to incorporate this lab way of seeing things because there's a huge amount of craftsmanship between a good idea and a good product. So we believe that peer-to-peer is truly about raising the costs of coercion and having come from the places where we come from, me, Brazil, Yaya, Egypt, we know how important it is to build censorship-resistant and biased technology for communication. And we see a bright future for video in the Web3 stack. So we are eager to explore and collaborate on research on implementations of peer-to-peer technologies that can bring cost efficiency to any layers of this ideal stack that's still a little bit abstract, just like peer-to-peer helps bring cost efficiency in content delivery, for example. And we are already collaborating with some projects in this space. We use a lot P2P for networking and for some other stuff. Yaya is going to talk about that. And we really believe the space is progressing and that these layers are all maturing, basically or generally from the bottom up. up to the point where we're going to be able to have applications more or less decentralized, but that can explore these new monetization ways. So we've built a JS library that's basically a peer-to-peer ingestion pipeline that allows one to interact with IPFS, Ethereum contracts, and play with some monetization models. Still on a testnet, not launched. And we've built a couple dApps, or a couple apps actually, basically an embeddable video player that does pretty good quality browser-to-browser streaming over IPFS, and a portal for uploading content that we are working a lot on productizing. So I'm gonna bring in Yaya so that he can give us a few words on the challenges of browser-to-browser streaming. And then I'm gonna wrap it up very, very quickly. Yaya, can you listen to us?
Good. Oh, okay.
There you are. So you'll have,
Sorry.
some minutes less, but please go on, enjoy.
Yeah, I'll just get to it then. So basically, Felipe told you guys about what we're trying to do here. So I'm just gonna get to the technical part. Basically, what we try to do is we use IBFS and Ethereum blockchain to give you a server in a tweet, an embeddable video player that you can drop anywhere and it would still work based on these two technologies. And I'm going to also go into details on how do we actually do this using only libb2b and the IBFS stack and a little bit of the blockchain to maintain state. So here's a quick example. Basically, you try to, if you want to upload a video to the network, you just require Paratii, and this works with Node.js or the browser. So if this is a file API, it will just function as well, and you just upload it. And there is, inside the Paratii.js, we have what is called the Paratii protocol, and it's basically an IBFS bit swap with few special messages along with the normal data fragments. We use this to basically allow the various agents in the network, so transcoders, file storage points, the binning nodes basically, to communicate and to exchange data, and also later on when file coin lands, it will probably integrate with that as well. So this is an example. This is just a transcoding event. And as you can see, it uses FFmpeg, so it has like a weird question mark in the format. And yeah, basically you can split the bitrate on different transcoders. So it's very generic, and it allows the network to basically use live peer at some moment when they allow batch processing. So we'll be able to use that as well. Once the downsampler is ready, again, it tells the client. This is all done through libb2b. So it's just basically a protocol built on top of that. And yeah, once you're done, you get a hash, and this hash points to the folder where the HLS fragments are. And it also generates thumbnails and all sorts of cool stuff along the way. The value here is, this is currently done on chain, but since we're in a testnet, there is probably there are probably few things that has to be changed once to get to production. But as I said, this is testing, so stay with me. Challenges. All right, this is why we're here basically. I'm going to start with browser limitation. As you know, the storage in the browser, there is a limit to it, and this differs from one browser to the next. The WebRTC is throttling for bigger files, and this is kind of, it isn't really obvious if you have a decent network. Like, I come from a place where the network speeds are completely terrible. I'm talking 2 megabits per second. So yeah, so you start to notice that there is like a flickering in between connecting and disconnecting and all of that, because the browser keeps blocking any sorts of big files. Yeah, and there's also high CPU network usage, but that's kind of inherited from the WebRTC layer. Yeah, so kind of a weird hack that if you the proto buffer message for the bit swap, if you just limit that to 64 kilobit or 32, you wouldn't really notice the browser disconnecting the peers. However, if you try to do a block stream on the connection itself in the libb2b layer, that doesn't really help the issue. And last time I tried to fix this, I kind of broke WebRTC transport, so PRs are welcome. This is a GIF. I hope it shows, like, if you look at the left lower corner, you'd see a beer flickering, and that's basically trying to get this file. And every time it gets a chunk, it gets disconnected, and so on and so forth. Limiting that would allow it to keep the connection, but again, it's non-deterministic to say the least at this point. The second challenge that we're having is dynamic adaptive bitrate streaming. So you got to figure out which resolution is right for the user depending on their connection. And in a centralized system, this is pretty straightforward. You measure the speed and you're good. But in a peer-to-peer fashion, there is, like, each peer has a different sort of upload and download speeds and different sort of loads. And that makes it a bit harder to define what's the suitable bitrate here. Also, based on the advice of Flavio, who's our advisor, and he runs the CBS video technology part, that if we could use IBFS DAG and the PubSub, we could probably create a little bit of a smarter system that will allow users in remote or bad areas to leverage their beer in a much better way. So this is a work in progress. There are a few papers, but nothing concrete yet. I was hoping to share something, but it didn't work out. So that's one of the parts. One of the major problems is, one of the major goals that we had is to try to embed this everywhere. And for that, for us to do that, there has to be few restrictions, and we're trying to cover it. So the time to the first bit is substantially longer. DHT isn't fully functioning in the browser, but the relays have been tremendous lately, and that's very good for the network, and a great job. Obviously, not all beers would have all the bit rates, so you have that as well if you reference the previous slide. And as you know, once the content is on the permanent file system, it's hard to be removed. So you got to have some kind of level. We have TCRs, which is token curated registries, to basically whitelist the content, but technically you can't really stop content from existing on that network as long as someone would host it. As I said, there are a few restrictions in order to get the player embedded in Twitter, Reddit, Telegram, all the other social networks. And you would see that the time for the first chunk has to be under 10 seconds, which is currently only achievable using the gateway to build the first chunk, at least. And the autoplay, this is actually a recent problem that Chrome stopped allowing our player to autoplay, which kind of sucks, to be honest. Yeah, so there are a few centralized methods that we currently use because the network is tiny. IBFS gateways are used to build the playlist for the video. So that's the file where all the chunks are, all the chunk hashes are. The gateway is used if there are less than 3 beers connected. So it's much harder to get a chunk at that level. So that's also used. The transcoder selection, which is done via the Paratii protocol, right now it's a bit random. It's not as efficient. We were hoping to use live beer as soon as possible, so probably be outsourcing this part of the stack to them and to other players that would integrate with us. And obviously there is an Nginx caching that is used on top of the gateway just to, give it that extra edge for now, and people can demo it without, any sort of weird user experience. But yeah, this is a terrible graph that I made very quickly. But as you can see, there is Nginx on the left side, and there is load balancer, which connects to the IBFS nodes. And there is actually an XHR uploader that we currently use because uploading is a bit problematic when the user has a terrible connection. So we use that as a fallback to get the raw file from the client to the transcoder as soon as possible, so they can just close their browser once that is done. and they can come back to see if the job is done or not. Transcoders are basically IBFS hybrid nodes that has FFmpeg and all sorts of cool other little video editing tools hooked up to it, like FFprobe and all of that, and a few APIs to keep track of who's doing what. And the Paratii protocol, which is on top of libB2B, can do exactly the same job that the centralized part does. So if you do have a good connection, if you do have a lot of peers connected, not a lot, but like more than around between 3 and 7 is usually optimum, you probably wouldn't need the centralized part. Yeah, that's kind of it. I can probably do a quick demo here. Let me exit this first. So yeah, I'm just gonna try to tweet something since this is server and tweet. Let's see if it plays first. Okay, so as you can see, this is you, Larry. I'm not gonna copyright issues, so I'm just gonna tweet it and see if it works. Okay. And that's my Twitter. Maybe, follow me, whatever. Just saying. And it should be playing. If we actually, I hope you guys see the console. And you can see here there is Swarm is connected. Okay, I'm just gonna pause this for a second. But as you can see, IBFS is connected, but this is probably still loading from the gateway at this point because I'm not seeing a lot of other events. But, oh yeah, debug is not up. But as you can see, I'm limiting like the max message size to around 128 kilobit. And that helps the connection to be smoother, as you can see. Yeah, that's pretty much it for me, I think.
That's good.
Yeah. Oh, my bad. I tried.
Perfect. All right. Thanks a lot. And maybe we have time for one question, or if we don't, we are on Gitter/Paratii video, so just come and make questions and chat with us. We're very happy to collaborate. And thanks again for the team at Protocol Labs for putting this up. I've never met EI in person before, and I still don't know if he physically exists because he didn't show up.
I do, bro.
And it's amazing that we have open source based layer technology that we can build on and that we eventually end up having teams all over the world collaborating upon. Sometimes we stop and don't realize that. And I just wanted to leave my final words here as for the bigger momentum playing out here and the fact that this is not about a currency, a network, or a platform, not about Bitcoin, Namecoin, Litecoin, colored coins, Ethereum, or anything. It's about open source bankware. It's about monetary policy at your fingertips. It's about a collaboration paradigm shift, ultimately. So I'm glad to be taking part of it and keep up with the amazing work. See you.